When we think of space travel, Mars usually takes the spotlight. But what if we looked a bit further? What if our destination was Jupiter, the largest planet in our solar system, home to colossal storms and a magnetic field so intense, it challenges our understanding. It may not have the charming rings of Saturn, but it offers something far beyond aesthetics, a collection of icy moons that could potentially host life, and a crucial role in helping us understand how our solar system works. So why would anyone even consider traveling to Jupiter? The most compelling reason lies in its moons. Even though Jupiter is a gas giant with no solid surface, it's surrounded by no less than 79 known moons. It's practically a mini solar system on its own. Among these moons, a few stand out: Europa, Ganymede, and Callisto. All of them have thick icy crusts, and beneath that, it's believed they hold vast underground oceans. If there's life beyond Earth, these hidden oceans are definitely among the strongest candidates to host it. But before we imagine arriving there, we need to face the journey. And it's far from easy. The distance between Earth and Jupiter constantly changes since both planets orbit the Sun at different speeds. At their closest, they're about 365 million miles apart. At their farthest, that distance can exceed 600 million miles. To put it in perspective, 600 million miles is like circling Earth more than 24,000 times. And if we tried to make the trip at 70 miles per hour, the average speed of a car, it would take roughly 800 years to get there. In practice, the average distance between Earth and Jupiter is about 483 million miles. With that number in hand, scientists have to choose: burn more fuel for a fast, direct trip, or save resources by using a longer, more efficient route. And this doesn't just depend on the technology available, it also depends heavily on the planet's positions. The alignment of celestial bodies is critical. If the planets aren't in ideal positions, travel time and energy costs go way up. But have we ever actually made it there? The answer is yes. Exploration of Jupiter began decades ago. In the 1970s, NASA launched 4 spacecraft: Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2. All of them took a direct route to the giant planet, but none stayed. Instead, they used Jupiter's gravity as a kind of cosmic slingshot to speed up and continue toward the outer solar system. However, 2 missions stand out: Galileo and Juno. These probes didn't just fly by Jupiter, they went into orbit and stayed for years, studying the planet and its moons in detail. To achieve this, they followed longer routes using gravity assists from inner planets like Earth and Venus to gradually increase speed while reducing the fuel needed to safely enter orbit around Jupiter. The first one to actually reach Jupiter was Pioneer 10. Launched by NASA, it took the shortest path possible and reached Jupiter in 640 days, just under 2 years. Despite the quick journey, it only came within 81,000 miles of the planet. It was a flyby mission, designed to capture images and gather data before heading off into deep space. Other probes like Pioneer 11 and the 2 Voyager spacecraft got even closer, about 13,700 miles, and took between 600 and 650 days to get there. But none of them stayed either. It wasn't until the Galileo mission that, for the first time, a probe entered Jupiter's orbit and remained for several years. To pull this off, Galileo used a method called VEGA, Venus-Earth Gravity Assist, passing by Venus first, then circling Earth twice before heading toward Jupiter. This journey took exactly 2,242 days, nearly 6 years, but allowed the spacecraft to arrive at just the right speed to be captured by Jupiter's gravity. Then there was New Horizons, one of the fastest missions ever launched. This spacecraft was actually heading toward Pluto but made a strategic stop at Jupiter. Traveling at 45,000 miles per hour, it reached the gas giant in just 405 days. By using Jupiter's gravitational field, the probe got an extra boost of 8,700 miles per hour, saving about 3 years of travel time toward its final destination. But there's a big difference between sending robotic probes and sending humans. That's where things become far more complicated. So far, the farthest a human has ever been from Earth is the Moon, and that happened over 50 years ago. Only now, with NASA's Artemis missions, are we seriously planning a return. To give you an idea, a manned mission to Mars would take about 9 months one way, or 21 months for a round trip. Applying the same logic to a journey to Jupiter, a crewed mission would likely take around 6 years. And that's just to get there. And here comes a major logistical challenge: food. According to NASA, a 4-person crew would need about 8,000 pounds of food per year. That means just to reach Jupiter, you'd need 48,000 pounds of supplies. And that's without even counting the return trip, or the need for life support systems, scientific equipment, special suits, and living modules. Beyond logistics, there are also serious dangers. Outside of Earth, astronauts are fully exposed to solar radiation and cosmic rays. Without the protection of our magnetic field, the risks of genetic damage and cancer increase significantly. And that's not all. Mental health becomes a major concern too. Spending years in isolation, far from loved ones, doing repetitive tasks under constant pressure can lead to anxiety, interpersonal conflicts, and even depression. No matter how intense the training is, seeing Earth as nothing more than a tiny blue dot in the distance changes anyone's perspective. Thankfully, new space technologies, like NASA's upgraded suits and plans for the Artemis missions, are being developed to better prepare astronauts for these kinds of challenges. The route a spacecraft takes to get to Jupiter also makes a huge difference. It's possible to take a direct path, like Pioneer and Voyager did, or follow a longer and more curved trajectory, like Galileo and Juno. The advantage of the longer path is the smart use of gravitational assists. When a spacecraft flies close to planets like Earth, Venus, or Mars to pick up speed, this physics trick allows the mission to save a massive amount of fuel, which is crucial for long-duration space travel. When a probe uses these routes, it relies on the planets being in just the right positions relative to each other. A planet's gravity can act like a slingshot, pulling the spacecraft in and then flinging it out at an even higher speed toward the next destination. This method taps into the orbital energy of the planet, and the tiny amount of energy lost by the planet is so small it's practically undetectable. In the end, choosing the best way to reach Jupiter, or any other planet, is all about finding the right balance between time, cost, and mission goals. Using more fuel might get the spacecraft to its destination faster, but it also requires bigger, heavier fuel tanks, which increases both cost and risk. On the other hand, saving fuel means taking a longer path, but one that allows the spacecraft to slow down at the right time and enter orbit safely. This is crucial for missions that aim to study a planet in depth, not just fly by and snap a few pictures. These quick flybys are actually very common. Many space missions are designed just to pass by a planet, observe it, take photos, collect data, and keep going. This is known as a flyby, and it's like space tourism. The probe doesn't stop, just enjoys the view on the way to somewhere else. But why is Jupiter so important? Because it's like a giant natural laboratory. Its moons hide underground oceans. Europa, for example, is covered by an icy crust that might be several miles thick. And beneath it, there are signs of liquid water kept warm by tidal forces caused by Jupiter's gravity. This type of environment, isolated but internally active, is very similar to the hydrothermal vents we've discovered at the bottom of Earth's oceans, places where life has been found even without sunlight. And that's not all. Ganymede, the largest moon in the solar system, is even bigger than Mercury and has its own magnetic field. Callisto, another huge moon, might also contain a subsurface ocean and is known for being less affected by Jupiter's radiation. This makes it a safer candidate for a future human mission. The good news is that new missions are already on the way to explore these moons. NASA launched the Europa Clipper in 2024, and it's expected to reach Jupiter's system by 2031, after taking a long, efficient route and gradually slowing down to orbit Jupiter accurately. This mission's goal is to study Europa in depth, flying over it multiple times to analyze its surface, composition, and signs of underground activity. Another promising mission comes from the European Space Agency, JUICE, the Jupiter Icy Moons Explorer. It was launched in 2022 and is scheduled to arrive at Jupiter in 2029. JUICE will explore Ganymede, Europa, and Callisto, aiming to better understand their conditions, geological history, and potential for life. These missions show that the interest in Jupiter and its moons isn't just theoretical. There's real investment in time, money, and technology to understand what's happening out there. After all, if we discover life in any of these underground oceans, it will completely change the way we see our place in the universe. Now, back to the question of space travel. If a fast spacecraft like New Horizons managed to reach Jupiter in just over a year, why do other missions take so long? The answer lies in the mission's purpose. If the goal is just to pass by Jupiter and keep going, the spacecraft can speed up as much as possible. But if the goal is to go into orbit, things are different. The spacecraft has to arrive slowly enough to be caught by the planet's gravity. If it's moving too fast, it will just fly right past. This speed adjustment is one of the toughest challenges in space engineering. Slowing down requires fuel and careful planning. That's why most spacecraft that orbit Jupiter follow longer routes with gravity assists and extended travel times. But what about Saturn? The ringed planet has always fascinated us with its beauty. Its golden glow in the night sky and its stunning rings, visible even through amateur telescopes, have captivated humanity for centuries. Scientists have studied it for decades, intrigued by its rings, its faint glow, its dozens of moons, and especially the possibility of life on some of them, particularly Titan and Enceladus. However, Saturn is even farther away. At its closest to Earth, it's about 746 million miles away, around 8 astronomical units, which is the distance from Earth to the Sun. When the two planets are on opposite sides of the Sun, the distance exceeds 1 billion miles. For reference, the shortest recorded distance between Earth and Saturn was around 745 million miles, back in December 1914. Missions to Saturn face similar challenges to those going to Jupiter. Probes need gravity assists to gain speed, since carrying enough fuel for a direct trip that ends with deceleration isn't feasible. The Cassini spacecraft, for instance, was launched in 1997 and didn't arrive until 2004, 7 years later, after using the gravitational pull of Venus, Earth, and Jupiter as stepping stones. Cassini was a landmark in Saturn exploration. It stayed in orbit until 2017, collecting data on the planet's rings, atmosphere, and especially its moons. Through this mission, we learned much more about Titan, which has lakes and rivers of liquid methane, and Enceladus, which shoots jets of vapor and ice particles into space, hinting at a warm underground ocean. Even fast missions like New Horizons, which took only 2 years and 4 months to pass by Saturn, showed that it's possible to reach the planet quickly. But again, that only works if the goal is a flyby, not a long-term orbit. The next generation will witness incredible discoveries, not just about Jupiter and Saturn, but also about Uranus, that quiet giant which still holds many secrets. Maybe we'll learn about its past, or about the origins of our solar system, or even how life might emerge under conditions completely different from Earth's. The future of space exploration is only beginning, and the journey ahead promises to be one of humanity's most fascinating adventures. With the rise of artificial intelligence, maybe we'll send autonomous robots instead of humans on the first voyages to these distant worlds. But let's leave Uranus, Neptune, and even Pluto for another video. We'll end our journey here. Share your thoughts in the comments. If you enjoyed this video, give it a like, subscribe to the channel, and turn on notifications. If you liked the topic, I've left 3 more videos in the description that you're going to love. Thanks for watching, and see you in the next video.